13. A current carrying circular loop of radius r is placed in the xy plane. Look at this. This is xy plane. I'll draw the figure. I'll interpret the question. Okay. XY plane. It's a previous question as well. Okay. XY plane. XY plane with center at the origin. So we have a coil kept at the center like this. All right. Kept at the center like this. Now, can you read it? Half of the loop with x greater than 0 is now bent so that it now lies in the YZ plane. They are talking about magnetic moment. I'll tell you how to approach the question. Look at this. This is which plane? This is x-axis. This is y-axis, isn't it? Okay. Okay. So first, in the first case, the coil is placed where? In the xy plane. So what is magnetic moment in this case? Question number 13. Can you tell me what the magnetic moment is? Magnetic moment is given by I into area. Am I correct? Don't you remember? That was the very first question we did today. Magnetic moment is given by I into area. I into pi r square. Now you're going to do what? You're going to split this. You're going to break this ring into two. Like this. Half the ring will be kept there itself. Okay. And can you see? X greater than 0. X greater than 0 means this part. That part will be bent and put in the YZ plane. Like this. So it will look like this. That is along the YZ plane. So it will look like this. Half of it. I can show you if I have like, I thought of taking a paper, but I forgot. So look at this. Imagine I have a circle like this. This is like a circular coil. Imagine it was held this way. Okay. Right. So the area is magnetic field is what? Current in moment is what? Current into area. Then I bend it over and kept it this way. Do you understand? This way. You understand? Do you understand? This is the first configuration where the entire coil is in XY plane. Correct. Whereas now this is what? Half of it is this way now. It is kept this way. You understand? One part is in the XY plane itself. The other part is in the YZ plane. All right. Now I'll tell you, second part's magnetic moment will be what? I can say for this half, what is the magnetic moment? Tell me what? I pi r square by 2. I pi r square by 2. Why? Because area is now half, right? The entire area is pi r square. So what is half of it? Pi r square by 2, correct? For one half, it is pi r square by 2. All right. All right. And what is the direction of it? I can put I cap because if I put the direction of current this way, look at that. The current is, the area vector is coming out. So I can put I cap to this. The area is in this direction, But what about the other one? For this one, the area is in this direction. Whereas for this one, the area is in this direction. Am I correct? See, when it is kept this way, the area vector is kept this way, right? But when you fold it in the middle like this, for this part, the area vector is towards you. Am I correct? Area vector is perpendicular to the surface, right? Towards you means what vector should you put? Not I cap. I'll put, for this part, I'll put outward is called K cap, isn't it? K cap, right? K cap. Now, for this one, what about this part? The area vector is this way. This part is called what? Minus I cap, right? So I'm writing for M, that part. This is like M2 is not yet completed. So I can write it this way. So M2 I'm writing, M2 is equal to I pi r square divided by 2. For this part, it is out. Out means K cap plus. For this part, it is what? I pi r square by 2 into minus I cap. So tell me how to find the modulus of this. M2 will be equal to, if you want to find the modulus of a vector, you know how to do it, right? You know how to find the modulus of a vector? This number square plus this number square. Am I correct? Modulus of xi plus yj is what? Root of x square plus. Modulus of a vector is taken how? I'll calculate it. Okay, so just see this. I square, tell me, pi square r square by 4 plus I square pi square r square by 4, which is equal to root of, this is 2 times I square pi square r square by 4. 4 and 2 are cut, it is 2. Correct. So when you take the square root of this, oh, pi square is there, pi square. So square root I into pi into r by root 2. I into pi into r square, that will be r raised to 4, right? That will be r raised to 4. This will be r raised to 4. So when you take the square root, that will be r square by root 2. Now this is the old value, right? I pi r square is old value. That is m. Now it is m by root 2. M by root 2 is less than the old value. M by root 2 is less than original m. So the answer is option A. It diminishes. The value, magnitude of magnetic moment now diminishes. That is answer to this. All others will be wrong. You can check the options yourself. All right, magnetic moment does not change. Magnitude of B at Z greater than R increases. Z less than R, Z greater than R is unchanged. All others are wrong. All of you understood this, but I'll do it again. Tell me, please. First case. Write the first case. Write the first case. What is the equation for magnetic moment? Magnetic moment is equal to current into area. First configuration, okay? First configuration, current into area. That is equal to current into area is what? Pi r square. Area is pi r square. This is the magnetic moment, right? I into pi r square. Look at the area. Area is pi r square. Is that part clear? Any axis, we usually assign any axis, no problem. It's up to you, Praveen. You can assign any axis. I just want to get the modulus only. If you don't use the vector treatment, it's very complicated. That's what. Okay. You'll have to visualize a lot. Right. So the magnetic moment, until here it's clear for everyone. Magnetic moment is I into A, that is I into pi r square. You can call it M1, equation number 1. Now let's draw the second configuration. Draw the second configuration. I'll try my best to draw a good figure, right? But I'm not sure. You have to draw half of it here, no? Half of it is still here. Half of it is still here, okay? Okay, you just bend it. Do you understand? Look at this, look at this, look at me, please. This was the original coil, okay? And then I just bend it through the middle because they say x greater than 0. This region is called x greater than 0. X greater than 0 part is bent over and kept in the YZ plane, okay? So it is bent and kept in the YZ plane. Draw the figure. This is my Z axis, okay? I'll use another color, say yellow. So do you have an impression that it is bent like this? It's bent like this. Okay. For the left half, where is the magnetic? Where is the moment? What is the magnetic moment? I'm writing M left half. Right. Magnetic moment for left half. You write MLH, magnetic moment for left half. Okay. Or we can draw it in separate figures. That would be better. You draw this figure. And then draw another one. Maybe this is in XY plane, right? First one half is XY plane. Let's shade it. I'm writing the magnetic moment for this. What is the magnetic moment for left half? I into, tell me, pi r square by 2 because area is half now, right? And where is the area vector? Area vector should be perpendicular to it, right? Perpendicular out means k cap, isn't it? Out means k cap. All right. Understood this? So draw the second half of it. Second half is this way. Second half is in YZ plane. For that, the area vector is where? Look at this. It's held this way. So the area vector is this way, right? This way or this way. Either way is fine. Understood? All right. So if I keep it this way, the area vector is towards me. You understand? Area vector is towards me. Understand? This was, area vector was this way. Now when I bend it, the area vector also turns around, right? Correct. Area vector is perpendicular. So what about M right hand side? I pi r square by 2, that is also half, into towards the left is called minus I cap. Both are vectors. So what is M dash now? Second magnetic field, second moment. I pi r square by 2, that's common, right? I pi r square by 2 common, right? Into k cap minus I cap, right? Correct. So I is common, pi is common, r square by 2 common. What is the magnitude of this? You know how to find the modulus of a vector? 1k, right? So 1 square plus 1i, right? So 1 square. So that will be what? We have made things simpler this time. I pi r square by 2 into, how about this? This is root 2. Correct. Correct. So root 2 and 2 are cut. You are getting root 2 now. So what am I getting for M dash now? M dash is equal to I pi r square by root 2. That is equation number 2. If you compare M1 and M2, M and M dash, you understand what? M dash is less than M. Original M is I pi r square. New M is I pi r square by root 2 only. By root 2 is somewhere around 70%, 0.707, 70%. Understood? By root 2 means it's only 70%. So obviously, new M is less than the old M. Okay? It's again one of the most complicated questions in this topic. Hope you understood this. Answer is option A. The magnetic moment of the coil decreases or diminishes. Is that clear now? Okay, so go back.